everyone and welcome to another IDTechX webinar. My name is Conrad Nichols and I'm a Senior Technology Analyst here at the company. Today we'll be talking and discussing more about the emerging trends for the future and economic development of second life electric vehicle batteries. This draws upon research from IDTechX's newly updated Second Life Electric Vehicles Batteries Market Report.
Very quickly, for those that may be more unfamiliar with IDTechX, since 1999 the company has been providing independent market research, consultancy and subscriptions on emerging technologies to clients in over 80 countries. And our topics extend beyond energy and battery storage, such as electric vehicles, energy and decarbonisation, advanced materials and critical minerals, 3D printing, wearable technologies, robotics and autonomy, sensors and haptics and much more. Our market reports cover technology assessments and scouting. We profile companies at conferences and through online interviews. We also size markets and provide forecasts in our reports also. IDTechX supports its customers at each crucial decision-making step. Through our reports, subscriptions and consulting services, we perform technology appraisals, for instance looking at benchmarking technologies or scouting new technologies, looking at market opportunities and requirements potentially to enter or continue participating in a market. And we may also look at providing commercialization strategies and other partnerships that may be available to you in your company, looking at potentially some of the smaller startups that are operating in this space already. IDTechX's market reports also provide ongoing analysis and trends in a certain market or technology area. IDTechX subscriptions give you access to more data as it's updated by analysts while they're updating their market reports. And this could be access to data such as company profiles, event summaries, research summaries, technology analysis, and premium articles as and when they're written. As well as this, subscriptions can give you access to analyst time and briefings, which gives you the opportunities to ask analysts questions about a certain technology area or market.
In today's webinar, we'll be discussing more about the Second Life EV battery market, the technology, and also provide a player overview and give a brief introduction to policies and regulations around repurposing and Second Life batteries. Then we'll be moving on to talking more about the cost bottlenecks in the repurposing process, and then some trends to impact both positively and negatively the repurposing costs for end-of-life batteries into Second Life technologies. We'll then be finishing with a summary and IDTechX outlook. This webinar is based on IDTechX's Second Life Electric Vehicle Batteries 2025 to 2035 market report, and in this report you'll be able to find 10-year market forecasts for Second Life EV battery technology installations and retired EV battery availability. There are analyses included in the report including Second Life battery technologies, markets, repurposer and end-of-life diagnostics players, regulations, repurposing costs and techno-economic analysis against first life lithium-ion battery energy storage systems. So first we'll jump straight in and talk more about the Second Life EV battery market, technologies and give a player overview as well. For a quick refresher, or for those that may be unfamiliar with the lithium-ion battery circular economy, once an EV battery has been manufactured, it will then go through its first life in an electric vehicle. Once it's reached the end of its first life, which will typically be at around 70 to 80% of the state of health or rated maximum capacity of the battery, these batteries will be recycled to reclaim the critical raw materials and then have these critical raw materials reintroduced into new EV battery manufacturing. These critical raw materials would typically include lithium, cobalt and nickel. However, prior to recycling, an EV battery at end of life could be repurposed or remanufactured for second life applications. And these key benefits would include maximizing the value of the battery, extending its lifetime and delaying recycling. As well, this could reduce the associated CO2 of the battery per total kilowatt hours dispatched over the entirety of the battery's lifetime. However, this key benefit is not very well recognized among policies and regulations currently. Some key applications of second life batteries include lower power electromobility applications such as for electric scooters and rickshaws, and more dominantly second life stationary energy or battery storage applications. In some cases, cells or modules in an EV battery pack at end of life could be replaced, and then the battery pack could have its first life extended in an electric vehicle. The recycling market is growing much faster than the second life battery market at the moment, and supply chains are continuing to be formed between automotive OEMs and recyclers such that these automotive OEMs can reclaim the critical raw materials from recycling. When we look specifically at the battery second life value chain, the automotive OEM will be the player responsible for collecting the EV and the EV battery at the end of its life. The end of life of an EV battery is typically defined as when this reaches 70 to 80% of its maximum rated capacity or 70 to 80% of its state of health. This is essentially the equivalent. A battery performance modeler or a grader or a tester or diagnostician, various terms can be described for these different players, will then typically be looking to use advanced grading technologies to quickly assess and determine the suitability of these retired EV batteries for second life applications. These batteries will then be passed on to a repurposer, who will then be repurposing the retired EV battery into a second life application, and this is most typically stationary energy or battery storage. So what IDTechX has observed the most in the second life battery market currently, especially within Europe and US markets, is once a repurposer has either repurposed at pack, module or cell level the retired EV battery into a second life battery storage technology, this will typically be for commercial and industrial battery storage customers. So this could either be a stationary system, where these systems could be used for optimization of renewable self-consumption, peak shaving or EV charging, or this could also be a mobile battery storage technology, and these would either be used for uninterruptible power supply, backup power at festivals, commercial events and construction sites, or also for EV charging. In some cases, repurposers also pass these technologies onto their distributors and installers to homeowners, and these will be for residential battery energy storage systems, such that these consumers can optimize their renewable self-consumption as well. In much rarer cases, there are some repurposers that also offer stationary grid-scale technologies, and these battery storage technologies can be used to provide ancillary services and energy shifting services to the grid as well. There are some rarer cases where a remanufacturer or a recycler may disassemble the EV batteries to module or cell level and then ship these back to an automotive OEM or a service workshop, who could be responsible for then replacing cells or modules in a pack and integrating this battery into an EV for first life extension applications. There are also some pretty rare occurrences of recyclers doing this same sort of thing as well, where they'll pass cells or modules that have been disassembled back to an automotive OEM, because these batteries could still be suitable for a lower power electromobility application such as an electric scooter or a rickshaw. When we look at the global second life battery market at the moment, IDTechX has identified 26 repurposers outside of China, 20 of these based in Europe, 5 in the US and 1 in South Africa. Most European repurposers are based in Germany, Spain, the UK, Switzerland and Belgium. Within China, while specific second life battery repurposers have not been identified, IDTechX expects that most of these second life batteries that are appearing in China are being mostly used for uninterruptible power supply applications or backup power applications for telecom towers in China. And on this basis, it's very likely that China is already seeing gigawatt hour scale deployments of second life batteries for these applications already. IDTechX's market report on second life electric vehicles batteries also includes key information on key repurposers' specific second life battery technologies, funding, partnerships, projects, installation targets and other relevant company information. The report also details key activity from automotive OEMs participating in this market, though activity from these players is seemingly more limited than in the recycling market, and this may suggest some hesitancy on the side of the OEMs for the economic case of second life EV batteries. On the policies and regulations front, more could be done globally to incentivize or encourage the repurposing of retired or end-of-life batteries for second life applications. Many of the policies that have been introduced in key regions with high demand for EVs and batteries generally only tend to skew these regulations or targets towards recycling rather than repurposing. When we look at the EU battery regulation more specifically, there is some encouragement of repurposing in there, however very little to push for incentivizing second life batteries, either from a regulatory or a financial perspective. For further information on regulations and commentary on accessibility of important battery data at end of life and extended producer responsibility, please refer to the IDTechX report. One of the key targets that's mandated in the EU battery regulation that is skewed towards recycling is minimum recycled contents in new industrial and EV batteries, which are enacted and must be achieved by the 18th of August 2031 and increasing by 18th of August 2036. And what's key here is that this minimum recycled contents targets means that batteries will require certain amounts of critical materials in these new batteries. and this may mean that automotive OEMs are prioritizing the securing of supply chain agreements with recyclers within the EU, which could be to the disbenefit of the repurposing market. And in this sense, OEMs are more likely to be, at the moment at least, prioritizing recycling business models as opposed to repurposing business models. And ultimately, this could be but one of the few key contributors to only steady second life EV battery market growth within the EU over the next few years. Having now provided an overview of the technologies, players and markets for second life EV batteries, we'll now start discussing some of the trends to impact the cost of second life battery repurposing. So first, almost as a prerequisite, it's important to understand the state of the first life or new lithium-ion battery energy storage system, or BESS, market. And so global deployments of first life lithium-ion BESS made annually have grown by 4 times in 2023 versus 2021, and some lithium-ion BESS manufacturers are already reaching annual gigawatt-hour scale deployments of their technologies. The prices of first life lithium-ion BESS continue to fall, and this is now into the range of $210 to $350 per kilowatt hour in European and US markets. And then when we look now at second life battery storage technologies, the repurposing process, as shown in IDTechX's analysis, amounts to around $250 per kilowatt hour for one battery storage system. Final second life BESS prices are therefore likely to be higher than this, and this means that repurposers are likely to be struggling to compete on final system price against new or first life lithium-ion BESS. And this has led to only steady second life EV battery market growth in 2023 and 2024. It must be remembered that second life batteries will inherently be worse performing than first life lithium-ion BESS, given the degradation and loss of capacity and potentially increase in internal resistance over their first life in an EV, and therefore repurposers have to generally offer their second life technologies at costs lower than first life lithium-ion BESS to be competitive. And here on your screen you can see the various parts that make up the overall costs for repurposing an EV battery into a second life application, and this can be broken down into 3 key buckets, including logistics costs, materials and components costs, and the manual intervention required for the repurposing process. And so some of the key bottlenecks identified by IDTechX that comprise a larger proportion of these costs would include that of the retired EV battery itself, and the testing and grading process, which requires a long time and therefore incurs high overhead costs because some manual intervention will be needed. Logistics costs are also not to be underestimated, and these can form a significant portion of repurposing costs too. While I'll now talk through some of the trends that can help to reduce or negatively impact repurposing costs in the future, the report from IDTechX includes detailed breakdowns of these repurposing costs, as well as providing a sensitivity analysis of different scenarios of final costs, where, for example, reduced retired EV battery costs, faster testing times, and larger EV battery pack scenarios are analysed to help reduce overall costs. Also, these detailed breakdowns of costs in the repurposing process have been informed directly from primary interviews with key repurposers in both European and US markets. Pack level repurposing already offers a means for repurposers to start reducing their repurposing costs. This is due to the fact that no module or cell level disassembly would be required, and therefore this saves time and therefore costs associated to labour that would be required to disassemble to module or cell level. It is also arguably the easiest method to scale repurposing across a larger volume of retired EV batteries due to the reduced time for repurposing per battery pack. However, module-level repurposing could offer some improved system performance due to being able to use the best performing modules. Also, in some cases, module-level disassembly may in fact be necessary, say if one of the modules is damaged or contains multiple cells with reduced capacity or high internal resistance, which would be reducing the overall performance of the pack. Depending on these factors, repurposers may choose to either repurpose at pack or module level rather than solely focus on one type of repurposing. However, generally speaking, repurposers will only focus on one type of repurposing process, and of those identified, pack level and module level repurposing dominate the market. Over the last couple of years, IDTechX has observed emerging business-to-business battery marketplaces which will be key in benefiting and growing the second life EV battery market. Key examples of these marketplaces include Currents, Circunomics and Clean Systems. These marketplaces or platforms facilitate the trading of retired EV batteries between OEMs and repurposers and potentially recyclers in the market as well. Batteries listed on these marketplaces will typically have key battery health information such as state of health and potentially internal resistance also listed. This would allow repurposers to view the state of health of battery packs or modules before they are purchased, and this would streamline their repurposing process and reduce testing costs, as this could remove the need for them to perform their own state of health tests. This, paired with greater data transparency, means that marketplaces are likely to strongly influence and increase the volume of retired EV batteries shipped to repurposers, and this will be key in growing the Second Life EV battery market. Without such platforms, Second Life repurposers will be more reliant on partnerships directly with OEMs for the wide-scale procurement of retired EV batteries. This can typically be a time-consuming and costly process while only seeing low-volume shipments, and therefore high-cost shipments with that too. Existing battery testing technologies to determine the suitability of these end-of-life batteries for Second Life applications include battery cycling to determine battery capacity and state of health, and electrochemical impedance spectroscopy to determine the internal resistance of these batteries. Only those batteries with a high enough state of health, typically 70 to 80%, and a low enough internal resistance will be suitable for Second Life applications. However, these tests per battery pack can take anywhere from 2 to 30 hours, which leads to high overhead costs as some manual monitoring may be needed. Also, cyclers can also exhibit a high capex and require a lot of in-house infrastructure and electrical infrastructure to house these. Therefore, this is not a very viable or suitable solution if multiple and a wider volume of retired EV batteries are looking to be tested for their suitability for Second Life applications. Going forwards, future technologies and advanced battery testing technologies will be looking to use machine learning assisted technologies to help grade these batteries in a much faster time, determining key metrics such as state of health and internal resistance. Some key technologies, such as those offered by Rejoule, for example, will look to determine these key metrics and the suitability of end-of-life batteries for Second Life applications in the order of minutes, and this is a much faster time and therefore will see much lower overhead costs be realised for battery testing. These advanced battery testing technologies could test the batteries while they're still in the vehicle via the OBD port of the BMS or the EV charging port, and this means that these technologies could be used at service vehicle workshops and dealerships, which streamlines the grading process for OEMs. This means that the batteries don't have to be removed from the vehicle and then tested for Second Life viability and then put back into the vehicle if they're not or still available for first life extension. This means that this can be streamlined and time can be saved. This therefore then could reduce the onus of grading from the repurposer, and this may see the OEM be more responsible for doing the grading and testing process. However, this then could lead into some arguments or some discussion around which type of player is actually providing the value when determining which of these batteries is viable for Second Life applications and which player will be developing the systems themselves. And therefore, grading costs could be shared between both of these parties if such a model were to exist in the future. The IDTechX report on Second Life electric vehicles batteries provides insights and a key summary of the players involved in Second Life battery assessment and diagnostics. It should be noted that many other players involved in cell testing and battery management system diagnostics could also have capabilities for Second Life assessment, as the techniques used are generally similar. And the players included in the table on this slide are those with the largest focuses on Second Life assessment, and there are various other ones involved in this market as well. IDTechX has observed several semi-automated battery disassembly pilots and projects that have occurred or are occurring in the market. Key players have demonstrated or are demonstrating semi-automated disassembly of battery packs to modules. The key benefit of these pilots and projects and the overall idea of semi-automated battery disassembly is that this will reduce the reliance on manual labour, reducing the time and therefore costs for disassembly. There are a couple of key examples that IDTechX has observed, one of these being B Planet Factory, which will be participating in the Battraw project, and B Planet Factory is a key repurposer. This project will be funded by the European Commission and will look to apply some semi-automated processes to the handling of EV batteries to separate their components, including cells and modules suitable for reuse. Liebherr Versatechnik also undertook a project for automated high-voltage EV battery pack disassembly, and packs that were disassembled successfully to module level were provided by Volkswagen. 2 robots were used to achieve this per EV battery pack, and the mean time for disassembly from pack to module level was around 2 hours. Ultimately, automating battery disassembly fully can be very difficult due to the need to disconnect wires and unscrew bolts in the battery pack, so some level of manual intervention will still very likely be needed. These projects have showed, or will hopefully show, some promise for EV battery disassembly via semi-automated approaches to reduce labour costs with this. This will help with scaling repurposing processes, and robot or cobot parameters could be tuned to disassemble packs of different design from different OEMs. This will be important so that repurposers are not restricted to specific EV battery models or battery designs in their repurposing process, unless if by design or partnership they intend to be. On the other hand, battery design architectures and form factors may still limit the feasibility of transferring automated processes between EV battery designs, and so the lack of EV battery design standardization is still likely to be a key challenge for repurposers. If throughput volumes of retired EV batteries in repurposing processes are low, this could also increase the payback time on robots or cobots, and so these technologies are only likely to be adopted for repurposing in larger scales once retired EV battery availability increases. IDTechX's market report also discusses key EV battery trends which could either negatively or positively impact second life battery technologies or repurposing processes. And so one of these, for example, is the removal of absence of the battery module, i.e. cell-to-pack or cell-to-chassis EV battery designs. These could, in theory, reduce the time required to disassemble to cell level, and therefore the costs associated with this, if a repurposer were to choose this repurposing route. However, this would more likely be a hindrance due to the use of more structural adhesives and welds in the EV battery pack. This would necessitate the use of solvents or heat to remove, which could increase disassembly costs. And so some key points to consider are that repurposers generally have complained to IDTechX in interviews with them at conferences that these designs are more difficult, time-consuming, and thus expensive to disassemble. Such designs are also to the disbenefit of recyclers, who may disassemble packs to module level prior to mechanically shredding these for the production of black mass. And therefore repurposers and recyclers alike have called for OEMs to start designing EV batteries with ease of disassembly and improved circularity in mind. As mentioned, the report also includes other key battery trends which are discussed and their impact on second life EV batteries or repurposing analysed in IDTechX's Second Life Electric Vehicle Batteries 2025 to 2035 market report. Many recyclers and repurposers alike have called for EV batteries to start being designed for easier disassembly to reduce repurposing or recycling times and costs. While cell-to-pack designs improve energy density and thus driving range of the EV battery in the vehicle, their greater use of structural adhesives and welds makes their disassembly more difficult and costly, and the lack of standardized EV battery designs can also necessitate the use of a skilled workforce to efficiently and safely disassemble various EV battery designs. Revenue sharing opportunities between automotive OEMs and repurposers could be put into place, such that OEMs receive some of the revenues from selling the second life battery to a customer or operating it for them. In exchange, the OEM could be incentivized to provide their retired EV batteries at lower costs, or start designing EV batteries with greater circularity in mind. This would, in theory, help to improve the economics of repurposing, and a key example would be the revenue sharing program introduced by HireWire, and this is called the Renew Collective Revenue Sharing Program. However, ultimately, it may be difficult to justify or agree that OEMs will be likely to forego a significant investment in new EV batteries to potentially realise only a minor cost benefit in 10 to 15 years' time, when those batteries would eventually be retired and then repurposed into second life. Moreover, the OEM could then be liable for some of the safety risks associated with the second life battery, and this may not only be placed on the repurposer, which in most cases in the current market is the case. However, repurposers could also look to take advantage of some other business models, such as battery storage as a service or renting second life batteries to customers over a shorter period of time, which could ultimately reduce the capex for customers and overall be cheaper than buying a first life or a new lithium-ion battery storage system. The IDTechX report discusses these different business models in more depth. IDTechX's Second Life Electric Vehicles Batteries Market Report provides the customer with access to over 30 company profiles, and this includes Second Life EV battery repurposers, battery performance testers and modelers for Second Life applications, and several lithium-ion battery recyclers that are already participating or may look to participate in the Second Life EV battery market. All of the profiles included in the report are shown here on screen. So, as the availability of retired EV batteries will grow over the coming decade, IDTechX forecasts that the second life EV battery market will be valued at $4.2 billion by 2035. Market growth has remained steady, though key trends could help to reduce costs of repurposing and improve how competitive these technologies are against first life lithium-ion BESS. Repurposing looks to maximise the value of the EV battery and the raw materials initially used, extend the lifetime of the battery and delay recycling. Repurposing could also help to reduce the battery-associated CO2 per kilowatt hour of total energy dispatched by the battery over the course of its lifetime, and this associated CO2 could be linked to the raw materials when the initial materials were mined, transporting the battery in different parts of the supply chain, and recycling the battery at the very end of life. Some key opportunities do exist in this market to reduce repurposing costs as discussed in this webinar, including business-to-business marketplaces for lower retired EV battery costs, faster grading technologies, and automated battery disassembly, among more. The market will grow more significantly as the availability of retired EV batteries increases, and there is the potential for some revenue sharing opportunities and for repurposers to capitalise on using other business models such as battery storage as a service or BSaaS and renting these batteries to customers too. However, there are clearly some key challenges that repurposers will need to overcome, and the reducing price of first life lithium-ion BESS has made it increasingly difficult for second life repurposers to offer their technologies at competitive prices to customers. The lack of policies or regulations that incentivize or encourage repurposing make this also very difficult for repurposers to pursue this business venture. More policies and regulations have a focus on recycling in key regions and recovering critical raw materials. The lack of standardized EV battery design and cell-to-pack designs can also complicate repurposing processes and add to costs. Thank you very much for attending and listening to this IDTechX webinar. If you're interested in purchasing this report or a subscription in which this report can be included, please reach out to us at research@idtechx.com. Thank you very much.